Just half a mile south of Ronald Reagan Washington National Airport, the flight paths for commercial and military traffic converge over the Potomac River. On the night of January 29, 2025, a Sikorsky Black Hawk helicopter sheared the commercial jet's outboard left wing. The impact forced the airliner into a violent 450-degree roll, sending it nose down into the freezing, dark water below. This satellite map shows the exact wreckage distribution. The Sikorsky's main fuselage sank mostly intact southeast of runway 33, while the fragmented pieces of the Bombardier CRJ-700 were scattered across the shallow riverbed. Recovery teams found no survivors. All 64 passengers and crew aboard the PSA Airlines flight, along with the 3 Army personnel in the helicopter, died in the crash. When National Transportation Safety Board investigators arrive at a scene like this, they operate on a strict principle. Catastrophic events do not occur because a single pilot makes a mistake. They happen when multiple defensive barriers fail simultaneously. The twisted metal in the Potomac is only the endpoint. To understand how 2 aircraft occupied the exact same coordinate in space, we have to look past the cockpit and trace the institutional systems that guided them there in the dark. This diagram shows the airspace exactly 20 seconds before impact. The closing distance between the descending CRJ-700 and the military transport is 0.95 nautical miles. Inside the airliner, the automated traffic alert and collision avoidance system triggered an audio warning. However, because the plane was already established on a low-altitude final approach, software limitations disabled the system's ability to issue specific instructions on how to evade the threat. This flight data readout shows a critical mechanical discrepancy on the helicopter. While its true radio altitude over the river was 278 feet, its barometric instrument registered an altitude roughly 100 feet lower, leading the Army crew to believe they were operating safely below the airplane's flight path. The data tracks the final 6 seconds. The helicopter instructor executes a slight left turn to correct their course. 1 second before the collision, the airplane's crew finally spots the rotorcraft and pulls their elevators to maximum nose-up deflection. With collision avoidance algorithms muted by altitude protocols and altimeters skewed by allowed hardware tolerances, the technological safety nets collapsed. Both crews were left completely dependent on their ability to spot a low-conspicuous object against a backdrop of city lights. 4 minutes earlier, approach control cleared Flight 5342 to execute a complex nighttime circling approach to runway 33. The crew was instructed to begin their maneuver upon reaching a specific visual landmark, the Woodrow Wilson Memorial Bridge. Meanwhile, the team inside the Ronald Reagan Washington National Airport control tower was managing an increasingly unsustainable arrival rate, processing a heavy mix of commercial airlines and local helicopter traffic. To handle the surge, supervisors made an operational decision to combine the helicopter control and local control positions. One controller was now responsible for sequencing commercial jets while simultaneously tracking low-flying rotorcraft on intersecting paths. This heat map graphs the local controller's radio communications in the final 2 minutes. The dense purple areas illustrate a constant, rapid-fire stream of transmissions with multiple aircraft. At 20:47:37, an automated conflict alert sounded in the tower, but the data shows the controller was actively keying his microphone to issue other clearances. The warning tone was effectively blocked by the tower's own radio traffic. When the tower finally instructed the helicopter to pass behind the commercial jet, radio interference clipped the transmission. Misinterpreting the scattered communications and the confusing array of lights below, the Army crew developed expectation bias. They firmly believed the passenger plane they saw was headed for a different runway. The air traffic controllers on duty were qualified and current. Their failure to issue timely safety alerts was a clear symptom of a workforce stretched far past its normal limits. The sheer volume of the airspace eroded their situational awareness, turning the tower itself into an active hazard. The investigation eventually isolated the geographic hazard. Helicopter Route 4 was charted as a vague corridor over the river with no defined lateral boundaries, and it ran directly beneath the established visual approach path for commercial jets landing on runway 33. Military flight crews had been routinely exceeding altitude limits on these DC routes for years. The U.S. Army had not implemented a fully functional safety management system that could have proactively tracked flight data, identified the altitude drift, and corrected the hazard before a collision occurred. The Federal Aviation Administration was already aware of the risks. Prior NTSB recommendations regarding advanced collision avoidance technology and the dangers of extreme scheduling strains at National Airport had been documented, reviewed, and ultimately left unaddressed across multiple agencies. The evidence points away from a sudden anomaly in the cockpit. Instead, it reveals a bureaucratic normalization of risk. Known hazards were filed into reports, warnings were logged, and the systems continued operating until the margins of safety completely evaporated. In its final report, the National Transportation Safety Board held the FAA responsible for the flawed route placement. They determined the probable cause of the accident was the agency's failure to evaluate available airspace data, coupled with a systemic over-reliance on visual separation to maintain traffic flow. The board issued 49 urgent safety recommendations, demanding comprehensive operational overhauls from the Federal Aviation Administration, the U.S. Army, and the Department of Transportation. These mandates included implementing independent safety culture reviews across the air traffic organization and enforcing strict, mandatory tracking of barometric altimeter tolerances in military aircraft operating near civilian airspace. Board Member J. Todd Inman summarized the investigation's broader conclusion, stating that the tragedy was not caused by a single person or action, but was the result of many failures across multiple systems. The wreckage recovered from the Potomac River proves that human eyes are not a sufficient failsafe. The aviation industry cannot use the concept of see and avoid to patch the holes left by unsustainable scheduling, ignored data, and broken institutional oversight.